My name is Pedro Galvão. I work at Hidromod, where I have the tech lead role, and I have the privilege of giving you a quick tour of the current state of the HiSea platform. I'm going to try to do the whole demo live, so these are very hot bits that were, I believe some of them were actually pushed last night, but I have a couple of slides just to get everyone on the same page about what the HiSea platform is. So please bear with me, and I promise we'll have some pretty pictures in just a few moments. So the HiSea platform is divided into HiSea services, which are just a bunch of web services. Like the name implies, they supply you something. But the relevant part is that they are cloud ready. So they use all of the latest trends of containers and Kubernetes and that sort of stuff. They can run on a private or a public cloud. HiSea will be demoed using DIAS, which is the European, the EU-funded cloud provider, but they also run in public clouds like Azure or Amazon Web Services, or even on private clouds. Next slide, please. So these services, I'll just quickly glare over them because they are relevant for the presentation I'll be giving next. I'll be reporting back to this slide a few times, but the first one is the authentication and authorization service. So this makes sure that all the data that we have in the platform, some of it is public, some of it can be private. So this service is responsible that only the data that you authorize people to see are available to them. We are using most of the latest trends like OAuth and Open Connect ID. In real people talk, that just means that you can use logins like Active Directory or Facebook or something like that to log into the platform, and then you have authentication and authorization behind it to make sure that you can see the data that you required. So this makes it very simple to propagate the tool inside your organization. We just need one email of an authoritative figure that then can give access to other users in the organization. Then moving on to the left, we have the data acquisition service. It sounds kind of boring, but it's actually a very important part of the system. All data comes in through the service, and this makes sure that data is in a format that all the remaining services can access. Of course, associated with it is data storage. We are currently using volume storage, but we'll be moving on to object storage pretty soon. Again, in English, that means that we are trying to keep the costs as low as possible of storing large volumes of data. The next step is data processing. So, sorry, yeah. So this is the second one that looks like a calculator. And data processing is a service that takes data that's already passed through the data acquisition service, and it turns it into something else. This can be as simple as calculating some index, like tricks for eutrophication or similar, or it can be something as complicated as running a full-blown water quality model, deltas, WK, or something like that. There's a small subset of these services that run on demand. I'll also be demonstrating this in just a while. Next comes the reporting service. Reporting is quite boring, so nothing like having a service to do it for us. I'll also be demonstrating this in just a little while. And finally, we have an alarm processing service, which is completely not developed. So I will not be demonstrating that today. It will be done in the next few months of the HiSea project. Next slide, please. So backend does all of this heavy lifting, but it doesn't really show anything to the end user. So I'll just give you a quick words about the front end before I start the demonstration. So the goal of a good front end is to look good and to stay out of your way. So having this in mind, next slide, please. We followed something called a dashboard design philosophy. I guess you can call it that way. But just a quick concept, I think everyone is familiar with this sort of application these days. So you have something called a dashboard, which is just a web page. And then on the web page, you can add different gadgets or widgets, depends on who you're talking to, and can work together or individually to display data. In the HiSea platform, both the dashboards and the widgets are configurable. So you can create new dashboards very easily and configure what each gadget is displaying and how it interacts with the other ones. This creates a flexible front end that we hope we can adapt to most of the user needs. So that being said, I'll start sharing my screen and doing the live demo. Oh, let me see if I can do it from here. I think, Sandra, I think you need to approve my screen sharing. Okay. Okay, hope everyone can see my screen. If not, please let me know in the comments. I'll be trying to check them. So right now, I'll put this full screen. So I'm just going to log into the system. The login part is currently disabled. So these are live bits. We are actually looking at the system running. This test deploy, I believe it's in Azure. But again, it could be deployed to any public or private cloud. We are using container technology, so it's easy to orchestrate this in different service providers. I'll start out by addressing what I think is the elephant in the room, which is satellite imagery. I'm going to open here the side menu. Again, this is configurable, but I won't go into that right now. And I have these side menu that tries to address most of the concerns that Mark talked about in his presentation. So I'm going to start with water quality. And I created a dashboard here called Old Days. I'm going to reach the old days, and to me the old days were about 1.5 years ago when the project started. So back then, if you tell me that you have satellite imagery for water quality, this would be what I'd have in mind. This is free data, by the way. Anyone can download it. It's in CMAMS. This is ocean color for chlorophyll. It gets updated, I think, daily. And it's quite impressive that we have hardware in space going around the Earth and taking this sort of pictures, and it's freely available to anyone. So you can see chlorophyll buildups in the North Sea or close to estuaries. But if we start zooming into the port level, and I'm going to zoom in here to Valencia. So we have here the Valencia port, which is, it's not by any means a small port. And if you look at it, it's 1 pixel, maybe 2 if you're, so 2 pixels, it's not very good. It's also close to land. And if you worked with this sort of imagery before, you can pretty clear that these boundary pixels are usually quite noisy because light reflects differently in water and from land. So this wouldn't be very useful if we're talking about port operations. However, these were the old days. So right now, inside HiSea, one of the partners, Argans, is supplying this sort of imagery. So let me just zoom in because to me, this is still amazing. If you look at the pixel size, it's about the size of a container. So we're talking about 10-meter resolution. Well, one of the requests that Mark talked about was if it was possible to sample water quality inside the port basin. And yes, you can. You just click on one point. You immediately get the values here on the side. If spatial resolution is a problem, spatial resolution is clearly not a problem. You can see that temporal resolution isn't either. So we have values about every 5 days. Sometimes, of course, we have gaps because it depends on clouds and that sort of stuff. So what we are seeing here is one of those gadgets or widgets. It can be configured to display any number of parameters. Right now, it's displaying chlorophyll. We can move back and forward in time. So if I move here for a different instance, like back here, it will automatically load the new image. This is available because data was gathered from the ingestion service and parsed and make sure that it's stored in the correct way. Here on KD, it's actually true color. So if we look at it, you see that there's a cloud there. So that's the reason when we move back here to chlorophyll, we have a hole back there. But to me, this is still pretty much amazing. Every time I click one of these points, what I'm doing is I'm sampling water in the basin of Valencia port without leaving my chair, and I'm doing it in the past. So technology is pretty close to magic, I guess. However, we still have this vertical line here, which is the current date. So we see the last image was from May 30th. We should have another one pretty soon. But the vertical line is the current date, and satellites cannot see into the future. And that would be where forecast water quality can come in. So here we would be using models. The advantage of using numerical models here is that first you can see a little bit into the future or forecast a little bit into the future, and you can also fill in the gaps that you get from satellite imagery. Here in the forecast for water quality, I'm actually only displaying EB, so it's also quite a coarse model, but Daltars is working on a very fine-grained water quality model for the Piraeus area. Unfortunately, we didn't get it in the platform in time to display here, but we will have that available in the next few months. Again, the dashboard itself and the services behind them don't really care where the data comes from. Once it's ingested, it's into a common format that can be shared and displayed in any of these gadgets. So you see, this is exactly the same gadget. I just changed the data source into a different provider. So I think this addresses quite a few of the concerns that were displayed by Mark, that were gathered in user workshops. And next, I'll move on to metocean conditions. So if we open here the side menu so we can actually read it. For metocean, the first dashboard I created, I'm trying to demonstrate the functionality of reports. So I mentioned the reporting service back there. And so you might be thinking, well, that's nice. We can get very fine-grained satellite imagery, but I don't really have time to log into a silly website and just click around to see how things are. I just really need to deliver a report to either my boss or to some compliance agency or regulatory agency. And the report service has you covered there. So reporting service can merge any of the data sources that are indexed by the platform, so any of the sources that I displayed previously, and create reports on the fly. For privacy concerns, we don't have the current report, so the last one I have here is from May 12th. But if you click on it, it immediately opens the report. This is for metocean conditions, but again, it could have been has easily done for water quality. These are simply time series or gridded data that is indexed in the platform. You can trigger some alarms on it. And these reports are completely flexible. They're actually made in Excel. And then the system just fills in the data in the Excel sheet and turns into a PDF. This, of course, can be sent via email, so you don't even have to log into the platform. You can just not even leave Outlook and still be using HiSea services or the HiSea platform. Next, we have here something called forecast image. This is something that we are experimenting with here in HiSea. And the way that it works is if I can direct your attention to the table here on top, it's something very similar to what you see in sites like WindGuru, or most ports, I believe, are used to working with this sort of information. What we have here is, instead of just giving you the values, we also give you an image of the closest image of what the conditions are when all of these values are conjugated together. So the way that we do this is we train an AI model with the hint-casted data and with a live webcam feed. And what the system does is that for each frame of the webcam, of course with some pre-processing to discard bad images, it associates that image with a set of values: temperature, tide, wind, sea, and so on. So then when we show it here on the gadget, we can give it that value, and it gives us back the closest image it can find. So instead of telling your users or users of the system that there will be a pointy arrow from the north and a pointy arrow from the south, you can just show him a picture and say, well, the last time these conditions were verified, this is what the ocean looked like. This is especially valuable in bad weather conditions, concerning that the camera could actually capture something, because these cameras are quite exposed, and sometimes when it's quite windy, they get foggy or dirty in any other way. But all of these can be processed by the system to discard this sort of imagery. So next, I'm going to move all the way up here to area control. So area control is the name that we are currently using for the port area. So this is, again, is Valencia port that we are using as an example. The sampling points that I believe are usually used by the port authorities are pretty close to these ones, but all the rest that I'm going to show is mock data. So the data that I'm going to show, of course, for privacy concerns, and we don't have access to the real samples that happened in the campaigns performed by the port. So all the rest is mock data, of course, for privacy concerns and because we don't have access to the data. So the goal of this part is to, while point sampling is very important, we would like to make it easier to include in the platform. So if you click one of the points, you can see all of the campaigns that happened at the point. Again, of course, this is mock data. You can see it in table or in chart format, mixing any point that you want to see. Of course, campaigns are usually sparse, so the mock data that we loaded are quite far apart. One of the things that we've added here is that we've used the ingestion service so that you can have associated with each value the actual lab report where the values came from. Again, this is mock data, which I try to make pretty clear by calling it a fake lab report and thanking you sincerely from the fake lab report. But you can see each value that is stored, you can backtrack it to the actual report bulletin that's usually signed and has some legal authority back from the platform into the report value. So that is pretty useful, but you might be thinking, well, it's okay, but that's a lot of work to put into the platform. Well, not really, because you just need to drag and drop your lab reports. So the way that this was imported was I have the same report here. You just need to drag it into the platform and it will upload. It will extract the data from the PDF file, fill it into the database, and keep a link between the original report and the data that was imported. Once data is here, it can again be used by any gadget or by any report, and you can import and export the data, mix it with the satellite imagery, mix it with the model results. So if, like we said, this is quite sparse, so you can just turn on satellite imagery and improve the number of samples that you are taking on your port by simply pressing a button. Trying to find a place where we actually have satellite imagery. So I'm about 20 minutes in, and I hope this is not, I'm throwing around a lot of concepts, and I still have a few more to display. So the next one is oil and marine litter. So this, I believe, was the last slide presented by Mark. And the goal here is to deal with oil spills. So the first point would be to detect if there is an oil spill or not. For that, we have this detection list here. So this is just a silly front end for a very complicated backend service that is running continuously over source image. So every time the data acquisition service finds a new source image, it gets imported, and then it gets processed to look for possible oil slicks. If a detection is made, it will be displayed here. This again is mock data. I'll try to make clear in each dashboard what's mock data or not. So of course this is mock data, but then you can click on one of the imagery. It will show you the georeferenced source image that was used. It will highlight the place where the slick might occur. You can even click it and get an estimation of the area. So once the slick is detected, you can move on to simulate how the spill will behave. So I'll move on here to spill simulation. Let me zoom in again here to Valencia port. I'll use Valencia port again as a sample. And so let's say that the same source image can be loaded here. And let's say that there is a spill somewhere here. I will turn the source image off again just to run the simulation. You can do a point simulation or you can draw a polygon. It's up to you. For now, for simplicity's sake, I'll just use one point. So you pretty much position it where you want the spill to occur. Let me just open the source image again. Let's say that it happened about here. And then you can click OK and start a simulation. So location, it's already done. The next step in the simulation is just saying when it starts and when it stops. Again, this can come directly from the source image, the date that the detection was made, but you can also change it by hand. Let me just input a nice date here. I'll put it on the 29/05. Let's put it at 7 p.m. This is a simulation I already did that has some interesting results. And let's run it all the way until the 30th. Also 5, also at 9 p.m. The next step of the wizard, so the goal of this, of course, to be as simple as possible, is to select the type of oil that you want to run in the simulation. There are a few options here. For now, I'll just leave it as a light oil. There are several processes associated with oil dispersion that depend on the oil that you have, like emulsification, spreading, that sort of stuff, but I'm not going into detail about that. Then you just click OK, and it will start running a simulation. So all of this, again, is happening on those backend services. So this was one of those on-demand data processing services. So it just sends all the requests back to the data service and run the simulation. So as a result, just close this, you have the trajectory of the center of mass of the spill. You can see how it moves through time. You can, if I just select here different instance, you see the date. Just take the levels off. So you see at this instance where it will be, what shape it will have, and then it will move all the way up to, so this one made landfall somewhere here close to this beach. Again, HiSea Platform is about gathering as much data from as many data sources as possible, like Dr. Gada was saying, and one of the important data sources for this sort of stuff is AIS. So this is real AIS data for those moments that I was showing you. And as I move forward and backward in time, we can see where the ships were. They all have their call sign, so you can look further into what each boat characteristics. And again, data fusion is always important, and close to a lot of these port areas are some webcams. So we can also see where they are. There's a webcam down here. And if I click it, it displays me exactly what the camera was seeing at the given time. So we can see if for some reason we can actually spot the split on the camera. So with this, I'll finish my live demonstration, and I'm going to ask Sandra, could you please put the PowerPoint back on?
Yes, I'll do that.
Okay, so I have just one more slide with some key takeaways. So this was a lot of tech to demonstrate in just 20 minutes. So I glazed over a lot of details, but I'm available for any questions that you might have. But the key takeaways I hope that everyone can take from the demonstration is that the first one is that the quality of satellite imagery these days is, to me, it's completely mind-blowing. And so this data is available, it's on the platform, and it's something that I believe ports should take advantage of. The second one is that the HiSea platform is flexible. It's flexible both in the front end and on the back end, especially in the back end. So all of those services can be mixed and matched together. It's very easy to include new processing tools, be them very complicated or simpler. And on the front end, it's the same. So you can consume HiSea without never logging into the service, without just receiving reports by email. So the added value that we are trying to bring with HiSea is the ability to merge different data sources, be it cameras, point values, satellite imagery. We want everything to be mixed together in a way that it's easy to access to the end user. And the final point is that we are developing HiSea in the open. This development effort has about a year, we're close to 1 year of development, but we are doing this in the open. So we are open both to suggestions, as to requests, and so contributions are welcome.